These are your 10-3A notes, operations with radical expressions. We're going to just continue with those operations. So yesterday's lesson was on adding and subtracting radical expressions, and today is going to be multiplying radical expressions. So we've already multiplied radicals, but we have never multiplied when they are being added or subtracted like a binomial. So this would require maybe distributing a radical through another radical or two, or foiling two radicals involving two binary expressions. So distribute or FOIL. Remember, just keep straight that when you multiply radicals, you multiply the coefficient by the coefficient, the number on the outside, and then you multiply the radicand by the radicand. So it's going to get a little crazy. You got to slow down and really keep your rules straight. You're going to want to sometimes, you got to know when you can change the radicand, when you can't, all that fun stuff. And then as always, we always simplify. We always look for perfects inside there that we can take out to make the problem simpler. So we got 6 problems. The first one is just a basic whole number 2 times 2 radicals. So if you recall, we're going to multiply the real parts and then multiply the radicals. So there's a 1 out in front of each of these radicals here. So we're going to multiply 2 times the 1, which is 2. And then it stays square root of 3, because there's no other radical to multiply the square root of 3 by, so it just stays the square root of 3. And then I'm going to distribute the 2 to the 1, which gives me plus 2 square root of 2. Okay, the square root of 3 and the square root of 2 did not change because there's no other radicals that's being multiplied there. And we can't add those together because they're not like radicals, so you're finished. So lots of different rules going on here. For number 2, we can pretend that there's a 1 out in front here that's going to get multiplied by the 3. So when we distribute the radical square root of 6, we're going to multiply it by 3. Okay, well, the 3 and 1 will make 3. There is no other radical that can go with 6, but it's still going to be 3 times the square root of 6, right? We're having the square root of 6 times 3 would mean we have 3 square root of 6s. And then when I distribute that to the square root of 2, it's going to become plus 1. And then you have the square root of 6 times the square root of 2, which makes the square root of 12. So it's going to be difficult because there's times where we can change the radicand and there's times where we can't. Yesterday when we added, we do not change them, but when you multiply, you do change them. That's that product property. So right now, the way they look, 3 root 6 plus 1 root 12, can't combine them, but I can see that 12 has a perfect living inside it. So I'm going to rewrite 3 root 6 plus, I'm going to break apart root 12 into 4 and 3. The 4 becomes a 2, and so I'm going to clean this up. 3 root 6 plus 2 root 3. You cannot do anything else with that because the 6 and 3 are not like terms. All right, this one we're going to FOIL. So just remember, foiling. First, outer, inner, last. Oh, boy. So you take the first term and multiply by the first term of the other. So you get 6 root 5. Multiply outside terms. So that's going to be the 3 times the 1 out in front, which is 3. And then the root 5 times the root 3, which makes root 15. Inner would be these 2 terms. So a negative 2 times a positive 2 is negative 4. And the root 3 just follows. And last, negative 2 root 3 times positive 1 root 3. So the negative 2 times the positive 1 makes negative 2. The square root of 3 times the square root of 3 makes square root of 9. So we go to clean this one up. We can see that 5 is fine, 15 is fine, 3 is fine, but the square root of 9 can actually transform into 3. And the negative 2 and 3 make negative 6. So what we have is 6 root 5 plus 3 root 15 minus 4 root 3, and then the minus 6. And because none of them are alike and none of them have perfects, that's as simplified as you can get. So when you have really ugly radicals like that and they're not matching, that's going to happen. You're going to have 4 different numbers, first, outer, inner, last, that don't combine. On the next slide, though, we're going to have things that actually cancel or combine and clean up. So it's kind of nice. So these are kind of your special cases. So the very first one, it's asking us to square the quantity 2 plus the square root of 5. Well, remember when we square quantity, we just get rid of the squared and we actually interpret what that means. To square quantity means to multiply by itself. So we're going to FOIL. 2 times 2 is 4. That's my first term. Outside is going to be the 2 times 1, which is 2, root 5. Inside, if you don't need to put the 1 there, just assume that it's there, okay? So 2 times 1 is 2, root 5. And then last is the square root of 5 times the square root of 5, which becomes a positive square root of 25. So I see a couple things that can happen here. I can see that 25, the square root of 25 is actually 5. And so now it's a whole number. And so I see that this positive 5 here and this positive 4 here can make 9 when you combine them. And then this positive 2 root 5 and another positive 2 root 5 tells me that I have 4 root 5s altogether. So remember, when you add or subtract, they got to be exactly the same, and you just push them together and add the number on the outside. Number 5, a little bit of the same thing, but this time both numbers are radicals inside. So when we expand this out, we're going to rewrite it as the square root of 3 minus the square root of 5 times the square root of 3 minus the square root of 5. First term, square root of 3 times square root of 3, square root of 9. Outside terms, a positive square root of 3 and a negative square root of 5 makes a negative square root of 15. Inside terms, a negative square root of 5 times a positive square root of 3 is another negative square root of 15. And last is the square root of 5 times a negative square root of 5 times a negative square root of 5. You always got to take the sign out in front. Gives me a positive square root of 25. So we got lots to clean up here. The square root of 9 becomes 3. The square root of 25 becomes a positive 5. And a negative 1 root 15 and a negative 1 root 15 makes a negative 2 root 15. So I'm almost done. The only last thing I have to do is put together this 3 and this 5. So 8 minus 2 root 15. And that's the final simplified answer. Last problem, some foiling. This time, though, a little different than 4 and 5. We're multiplying the same things in 4 and 5. This time we're multiplying conjugates. So I don't know if you're familiar with that term or not, but when the plus and the minus sign, okay, they're not opposites, just that middle sign is opposite. So when that happens, crazy things occur. So we're going to multiply. 5 root 3 times 5 root 3 makes 25 root 9. Multiply outside, multiply inside. And then we're going to take that first term and multiply it by 6. Plus 30 root 3. And we're going to take the two inside terms, negative 6 and positive 5 root 3 gives me a negative 30 root 3. And last, negative 6 plus 6 gives me negative 36. So lots of cleaning up to do here. The square root of 9 becomes a 3. Circle it with a 25. That makes 75. The positive 30 square root of 3 and the negative 30 square root of 3 cancel each other out. I had positive 30, negative 30. I don't have any. Or 0 times the square root of 3 is just 0. So all I have to do now is subtract the 36, bring down the 36 from at the end. 75 minus 36 has helped me out. 39, I believe. And you are all finished. So just remember to keep your rules straight. Make sure that you're going slow enough and that you show good work. Just checking my answer there. All right. So your lesson summary. I'd like to know what number is always in front of a radical if no number is written. And then I want you to multiply, FOIL those two quantities. Good luck.